welcome back. So, you've got this amazing network design on paper, but how do you actually make it real? Today, we are diving deep into the provision workflow in Cisco DNA Center. This is the critical stage where all that planning, all that policy work gets turned into live configurations on your network devices. Let's get right into it. Here's what we're going to cover. First, we'll get a handle on the provisioning workflow itself. Then, we'll look at the magic of automatically onboarding devices with plug-and-play. After that, we'll see how to manage our device inventory, build the SD Access fabric, connect our users and endpoints, and finally, light up some really powerful advanced services. All right, let's kick things off with Section 1, the provisioning workflow. Think of this as the bridge between your design and the actual deployment. This is where those architectural plans you've made meet the physical hardware, and everything gets configured and brought to life. Now, it's really important to get this. Provisioning is way more than just pushing a config file. It's the whole end-to-end process, right? It's about onboarding a brand new device, getting it under management, and deploying all the necessary settings and security policies to make it a fully fledged, functional part of your network. Inside Cisco DNA Center, the provision application is laid out in a really logical way, broken down into these three areas. First, you deal with the physical stuff, the devices. Then, you build the logical fabric that sits on top. And finally, you enable the value-added services. And that's exactly the path we're going to follow. So let's dive into that first major task, onboarding our devices. We're going to focus on automating that day zero deployment using Cisco's plug-and-play, or PNP. Honestly, this feature alone is an absolute game changer. It can dramatically slash the operational costs that come with manual device staging. This slide here, it visualizes the PNP process as a simple, repeatable cycle. It's beautiful. You create a template, you use that to build a network profile, you assign that profile to a site, add your physical devices into the system, and finally, you claim them. This becomes your core loop for super fast, consistent, and automated onboarding. The real power of PNP, though, is its flexibility. You can pre-provision devices before they even show up on site. You can reactively onboard a new device that just popped up on the network, or you can even sync your entire inventory straight from your Cisco Smart account. It gives you total control over how new hardware joins your network. So this first method, planned provisioning, is exactly what it sounds like. Let's say you know a new branch office is coming online. You just define the site, create the device profiles, specify the exact software version, and upload a list of serial numbers. Then, when the technician on site plugs in the hardware, it phones home and configures itself. All automatic. Zero, and I mean zero, manual CLI work. Okay, but what about when things don't go according to plan? That's what option 2 is for. A new switch gets added to the network without being pre-provisioned. No big deal. It just shows up in the DNA Center inventory as unclaimed. From there, you just find it, claim it, assign it to a site, and push the right configuration all from the GUI. Easy. And this third option, the Smart Account Sync, well, this one is just incredibly efficient. By linking your Cisco Smart Account, DNA Center automatically pulls in and populates your inventory with all the hardware you've bought. The devices are just sitting there, waiting. As soon as one gets plugged in, you just claim it and assign its role. It's that simple. All right, so once your devices are onboarded using one of those PNP methods, they all land right here in the device inventory. You need to think of this as your master database, your absolute single source of truth for every single piece of managed hardware on your network. And this view, this is your single pane of glass for all your hardware. You can see you get everything you need at a glance: the device name, its IP address, where it is physically, its status, and its role in the fabric. You can search, you can filter, you can sort this to find exactly what you're looking for, instantly. But this inventory isn't just a static list. It's an action hub. It's a command center. From right here, you can assign a device to a site, define its role, like making it a border node to connect to the outside world, or an edge node where your users connect. You can push software updates or even kick off a whole device replacement workflow. It's your central spot for all hardware lifecycle management. Okay, so our devices are onboarded and they're being managed. Now for the main event. It's time to build the SD Access fabric. This is the intelligent overlay that truly unlocks the power of software-defined networking. The key thing to wrap your head around here is that a fabric is a logical thing. It's a construct. It takes a whole bunch of physical devices and lets you treat them as a single cohesive system.
And it's this abstraction that makes powerful features like network virtualization and policy-based segmentation possible.
And you can see exactly how it works right here. Within a given site, you get this awesome topology view of your devices. From there, you literally just click on a device and assign its role: control plane node for management, border for external connections, or edge for user access. It's a really visual and intuitive way to build out your fabric. So what happens when you have multiple fabric sites? Well, you connect them using a transit network. You've got two main flavors here. The first, SDXS Transit, uses native fabric tech like Lisp and VXLAN to create the overlay tunnels. The result? One big, seamless end-to-end fabric. The second option, IP-based transit, lets you use a traditional IP network, but it does require a bit more manual work to map things like your VRFs between the sites. So our infrastructure's built, the fabric is live, but it's kind of like an empty highway right now. The next crucial step is host onboarding. This is where we get your actual users, computers, phones, and IoT devices connected to this new intelligent network. First things first, you have to define how endpoints are going to authenticate. You can pick a predefined template like closed authentication you see here. This is typically going to enforce security standards like 802.1x for corporate devices, or maybe MAC authentication bypass. You'll hear that called MAB from Simpler Things. The whole point is to make sure only authorized devices can get on the network. Next, we've got to connect our logical virtual networks, our VNs, to some actual IP addresses. As you can see right here, we're associating the campus VN with a specific IP address pool. So now any device that gets placed into that VN will automatically get an IP address from that specific scope. But what about those devices that can't do dynamic authentication, right? Things like a printer or maybe a building management sensor. For those, you've got static port assignment. This interface lets you pick a specific port on an edge switch and manually assign it to a virtual network and a security group. This gives you a static, totally predictable connection for those non-dynamic endpoints. And we've done it. The fabric is provisioned, devices are onboarded, hosts are connected, the network is fully operational. The very last step is to layer on those advanced services that really take advantage of this powerful new architecture. And just look at how simple this is. From this one Services tab, you can enable these powerful integrations with just a few clicks. You can turn on StealthWatch security analytics and get deep visibility inside your encrypted traffic without even having to decrypt it. You can enable application visibility to really understand what's running on your network. Or you could even use app hosting to push applications directly onto your network devices. It's pretty incredible. And that brings us to the end of our look at the SDA Provision Workflow. From the zero-touch automation of plug-and-play all the way to the one-click enablement of advanced security services, this whole process really does fundamentally change the speed and consistency of network deployments. So the question to leave you with is, which of these automated steps would make the biggest difference in your world?